did some initial runs on the proton with our AmpliSeq experiment in the nasal epithelium. And I would say the beauty of the proton is it gives us many more reads. So the nasal epithelium experiments that we designed, we originally ran on the PGM, and the PGM running 316 and 318 chips, it gave us the number of reads that we needed to validate our experiment and also to run our experiment in a sort of pilot fashion. Now we can run full experiments on the machine depending on how many amplicons that we want to include in the experiment. But say with an experiment with a lot of amplicons that we want to measure the expression for, and then if we want to scale that up, then the proton with its speed and the cost per subject is just at a price point where it makes it perfect to transition the experiments over to the proton. Something that's important to my laboratory is the ability to iterate experiments. So although it's helpful to have a lot of data, sometimes you want to produce a small amount of data to test your hypothesis, reformulate your hypothesis, and then go through the next experimental cycle. And that allows us to adjust and not spend tremendous amounts of money or time on leads that really end up in a dead end. And that is really, I think, the biggest strength of Ion Torrent and the proton is that I can generate data in a single day. The mapping is automated. So to get from the hypothesis to a result and a decision about how to move forward off that hypothesis is a very quick process. And it's a very competitive world in science. We're all trying to make discoveries to improve the health of the patients that we're interested in. And the ability to turn on a dime in terms of your research direction and the hypotheses that you're testing, the experiments you want to do, I think is invaluable. And there's really no other next-gen sequencing platform that allows you that sort of turnaround in terms of your experimental cycle.